Hi, everyone. My name is Ed Zimmermann. Welcome to Ed Talks, the energy storage podcast, where we look at trends within the industry and how they are impacting manufacturers like us and also the OEMs that are deploying systems throughout the market. So today we're going to be speaking about the different use cases for energy storage. We've had the opportunity to talk about the impact of design, the impact of, procurement and human resources, and all these other aspects of the energy storage sector from a manufacturing perspective. But we haven't really had the chance to look at where these systems are used, why they're used there, and which technologies make the most sense for the different use cases. And that's really going to be our objective today. So we'll start right off because we got a little bit of ground to cover here. The very first one I want to talk about is frequency management. So this is not something that I think people are really aware of outside of the industry, but it's a really important early use case and continuing use case for energy storage systems. All of the alternating current power distribution systems that we have around the world, here in North America at 60 hertz, in Europe at 50 hertz, the frequency at which power is provided is very important in order to ensure that the systems that consume that power continue to function correctly. And as your demand goes up, your frequency can be impacted, it drops, and eventually you're going to reach a point where you start having brownouts and blackouts as a result of this. So energy storage systems allow us to keep that frequency in the acceptable range as the consumption of power fluctuates throughout the course of the day. That means we're going to continue to provide very high quality power to the grid and make sure that the users of that power don't see brownouts and blackouts and things like that. And so that's an early use case for energy storage. It continues to be a very important application, and we'll probably see that continuing to grow. And I'll touch on the impact of that from a C&I perspective a little bit later on. Another important use case, and this is one that certainly does get a lot of attention, is peaking. So what is peaking? So throughout the course of the day, our consumption of power varies. During the mornings, it's very high. People are getting up, they're starting their day, facilities are getting their equipment running, and so our demand in the morning is very high. The same thing happens again in the evening. People are getting home, they're making dinner, they're doing laundry. So we have this sort of flow of power that is high in the morning, high in the evening, and relatively low during the middle part of the day. Now, traditionally, we would manage this with peaker plants. And what is a peaker plant? It's a power plant or a power storage system that can provide a large amount of power very, very quickly for a relatively short period of time. And this was achieved with gas turbine units or pumped hydro being sort of the original energy storage medium that people may be aware of. The energy storage sector today is really addressing those peaking requirements very, very well. And so a lot of the installations that we see are peaking related. It's allowing us to downsize power plants or eliminate traditional fossil fuel power plants. And it also drives the capabilities that we see in these traditional lithium ion systems. So these 1 to 4 hour duration lithium ion systems, those correspond very well to peaking periods where you need that additional power for 1 to 4 hours, in the morning and in the evening. And then what those systems are doing, of course, is during the course of the day where our demand goes down, they're charging themselves back up. So there's a couple of different advantages here. First of all, for consumers of power, electricity during peak hours is generally speaking going to be charged at a higher rate. And so there is a significant advantage to consuming power that was stored outside of peak hours to keep your costs down from a consumption perspective. And additionally, it's allowing us to eliminate, like I said, these traditional fossil fuel plants like gas turbine plants that are installed to provide that peaking support on an as needed basis. Now, peaking doesn't just occur on a daily basis. That's majority of the requirement. But we also have what's called seasonal peaking. And so if you live in the south and you're exposed to very high temperatures during the summer, obviously electricity demand goes up because of the need for air conditioning. Now you have an opposite situation in the north where during the cold winter months, your energy demand goes up because you need to heat your homes. So that type of seasonal peaking is something that the industry obviously knows it needs to address. The problem there is you need to be able to store power for exceptionally long periods of time. Diurnal or daily storage, or really the objective would be seasonal storage systems, so that in northern climates we can store excess power over the course of the spring and summer to release it in the fall and winter for heating needs. And in the south, we would store that power during the winter months and make it available during the summer in order to support our air conditioning needs. Now, the number of systems that are available that can achieve this, relatively small. And this is a big focus of research right now. Flow batteries have the opportunity potentially to meet some of that demand because they can offer very long duration storage. Even more exciting than that is systems that are using hydrogen, so metal hydride based systems. And those metal hydride based systems that are leveraging hydrogen and fuel cells and special metal compounds to store the power, they offer, seasonal storage. So we could really collect it during those off seasons and actually store it for months at a time and release it on as needed basis. Very, very important focus of research and a very exciting development in the industry when we see that starting to hit the market in the coming years. A third, obviously, very popular and well-known application of energy storage is storage tied to renewables. So obviously, as part of the overall desire to remove ourselves from fossil fuel generation of power and adopt the renewables, solar and wind being, the chief, technologies there, those obviously are variable. Sun's not always shining, wind's not always blowing. And when the sun is shining or the wind is blowing, we may not need all of the power being generated in that moment. So we need to have a way to store it for when we do require it. So energy storage systems, really, lithium-based systems, flow-based systems, liquid cell-based systems, all of those are being leveraged right now tied to renewables. And the IRA has a lot of provisions in place specifically to promote the combination of renewable generation with storage. So here again, we're using lithium systems. Some of the manufacturers of lithium systems are offering solutions extending into the 8-hour duration range, which is somewhat suitable in an application that's tied to renewables, but we're really looking for the long duration storage again. And so systems like flow batteries and liquid cell batteries that can offer that 10, 12, some cases up to 100 hours of storage are really ideally suited to being co-located with, these solar farms or wind farms, so that we're capturing that power when we don't need it, and we're releasing it when we do, despite what the sun or the wind may choose to be doing that day. Now, the last application for energy storage that I want to speak about is what we refer to as C&I, commercial and industrial. And there's a lot of different ways that commercial and industrial consumers are going to be leveraging energy storage, and they're going to be using different technologies as well. If you look at big consumers of power, and especially big consumers that need very high quality power, so we're talking server farms, we're talking semiconductor manufacturing, especially important given the passage of the CHIPS Act and how we expect that industry to grow. These industries need a reliable source of power, and they're big consumers of electricity as well. Having local energy storage is going to allow them to ensure the quality of the power they're receiving, regardless of what the grid is up to at any given moment. It's going to allow them to potentially leverage local renewables. So a lot of companies are looking to install solar panels on the roofs of their facilities to help offset some of their consumption. It's also going to allow them to use stored power during periods where power from the grid is more expensive. So we spoke about that earlier when we were talking about the way energy storage is supporting peaking requirements. All of these things, very, very critical to commercial and industrial users. And most of those applications are going to be using lithium-based systems because the power density they provide, very, very small footprint, very quick response times, really ideally suited to those applications where we want to capture locally generated solar or replace a genset or ensure quality power. Excellent applications of the technology. And another very important, from a C&I perspective, application of energy storage technology, and one that I think, given the events this past winter where EV vehicles all over the United States because of cold snaps were, stuck in the streets, is the use of energy storage as part of DC fast charging applications. So this is one that certainly CMP is engaged in. We have a couple of clients who are actively targeting this particular market. In order for the electric vehicle industry to truly develop, DC fast charging, the ability to charge an electric vehicle very, very quickly, instead of a few hours, a few minutes, is going to have to be in place. And hundreds of thousands of these charging stations are going to be deployed across the United States. And some of this is supported by a government act we spoke about previously, the NEVI Act. In order to support that level of charging infrastructure, we're going to have a lot of energy storage on tap. At the end of the day, kilowatts are kilowatts, whether they come out of a gas pump or they come out of an electric cable, you need to provide that power. And the grid right now simply was never designed to fill the gap that is being created by the needs of electric vehicle charging. And so having this energy storage co-located with charging systems so that we're not browning out local grids, so that we can charge large numbers of vehicles very quickly, is going to be absolutely critical. So those are the things I really wanted to speak with you folks about today. Some of the different use cases, some of the technologies that are really best suited to meeting those particular needs. We would love to hear from you. What did we miss? What did we not talk about? What are you aware of that we're not aware of? New technologies, new use cases that are emerging. We would absolutely love to hear from you. And of course, don't forget, please subscribe to our YouTube channel. We're going to be posting more and more content as we go, hoping to have a few more interviews as well to share with you, which is very exciting. And once again, like to hear back from you. Check us out on LinkedIn, check us out on YouTube. Hope you folks have a great day. Thanks so much.